Hello everyone, welcome to the application of calculus. Today we are going to study the cumulative distribution function. A function closely related to the PDF, or we say probability density function, is the cumulative distribution function, or we say CDF, which for a random variable x is a function f defined by that f of x is equal to the probability of capital X less than or equal to little x. This function is defined for both discrete and continuous random variables. For a discrete random variable, the CDF is a step function that takes a jump of pi at the value xi. For a random variable x that takes on value on the interval capital AB and having PDF f of x, the CDF actually is equal to the definite integral. We can see this picture, that capital F of x is equal to the definite integral of little f on the interval a to x. And x is between capital A and capital B. Consider the domain of x. We can get that for x is less than a, the CDF f is 0. Similarly, for x is greater than b, the CDF is 1. Since the probability of being less than or equal to the value that is greater than b is 1. The CDF is defined as accumulated area under the PDF. Now, let's see one example to discuss the relationship between PDF and CDF. Jack, would you like to read this problem for me?
Okay. In reliability theory, the random variable is often the lifetime of some items, such as a laptop computer battery. The PDF can be used to find probabilities and expectations about lifetime. Suppose that the lifetime in hours of battery is a continuous random variable x having PDF like this. A. Verify that this is a valid PDF and sketch its graph. B. Find the probability that the battery lasts at least 3 hours. C. Find the expected value of the lifetime. And D. Find and sketch a graph of the CDF.
Wow, this is a very long problem. Thank you so much, Jack. What do you think about the first question?
Okay, in order to verify it is a valid PDF, we need to prove that the probability on the total interval is 1.
Okay, very good. Now let's solve it together. The first problem. For all of x, you see fx is greater than or equal to 0. And the definite integral of PDF on 0 to 5, we can integrate that by the polynomial functions. We can integrate and find that the value is 1. And we can see the graph of the PDF is given in this figure. Second, the probability of x is greater than or equal to 3 is given by this integration. And it's integration of the PDF on the interval from 3 to 5. Again, we can integrate that by polynomial integration and to find the value. The third one, we need to find the expected lifetime. So the expectation is equal to x times PDF and take the integral. Take the integral on the whole interval 0 to 5. So we can find the definite integral and solve that. The expectation is 3 hours. Now let's see the fourth one. For x between 0 and 5, the accumulation function is equal to the definite integral of PDF on the closed interval 0 to x. And remember that because the upper limit is x, so this definite integral leads to a function. We see that when x between 0 and 5, it is this accumulation function. And when x is less than 0, this function is 0. And when x is greater than 5, according to the domain, we will find that this function is equal to 1, because the probability for the whole interval is 1. So we can draw the graph of the function like this. We learned the cumulative distribution function and its properties in this lesson. CDF is a very useful concept in probability. I hope you like it. That's all for this section. See you next time.